In today's section 4.2, we're going to talk about solving systems in three variables. The approach that I'm going to give you is by elimination. So it's basically what we talked about yesterday, except with more variables, and you're going to repeat the process a few more times. What you'll notice is that you'll see three variables in each equation, and there are three of them. At the end of this video, I'm going to show you visually what we're actually looking for, but let's talk about how you solve each coordinate or each point in the coordinate. So I'm going to start by labeling each one of the equations, A, B, and C. And what I'm going to do is I'm just going to make a decision to cancel out one of the variables. It really doesn't matter which one, but you need to be consistent. I'm going to choose to cancel the y's because I see that A and B would cancel right away. And what you're basically going to do is you're going to do elimination 3 times. And the idea is to knock it down from 3 variables down to 2 variables and eventually from 2 variables down to 1 variable. So what I'm going to do first is I'm going to take equations A and B. So I'm only using 2 at a time. 2x minus y plus 3z equals 13, and x plus y minus z equals -2. Once I have them written and lined up, I'm going to still cancel out the y's, and we're going to add them together. So this becomes 3x, y's cancel, plus 2z equals 11. I'm going to label this new one D, okay, because it's a new equation. Then what I'm going to do is I am going to take another combination from A, B, and C. I cannot have it the same combination as A and B, so it needs to be different. And I'm going to do the same thing. I'm going to eliminate. So I'm going to use B and C this time. And I'm going to, again, I've got to stick with the same variable. That's really important. So in order to cancel this out, I'm going to multiply by 2. And you're going to get 2x plus 2y minus 2z equals -4. The bottom one's going to stay the same. And I noticed right away that those aren't going to cancel because they're plus if I try adding. So I'm going to distribute a negative to each one of those. That'll make it easier to keep track of. So now I'm going to add those together. This is going to be x. This will now cancel. This will be 4z. And then this will be 17. I'm going to label this E. Now, once I have the two new equations, what you should hopefully notice is that in D and E, they have the exact same variables. That's important because we chose to get rid of the y's. Now what I'm going to do is I'm going to take D and E, and I'm going to use these two new equations to cancel out another variable. So again, I'm going from 3 variables to 2 to 1. Now, I'm going to choose to get rid of the z's, and I'm going to do that by multiplying the top one by -2. What that's going to give you is -6x plus a -4z equals -22. And then I'm going to have x plus 4z equals 17. That's going to give you -5x equals -5, x equals 1. Now that I have one variable, I want to backtrack. I'm going to go here, plug it in. So I'm going to have 1 plus 4z equals 17. So 4z equals 16, and then z equals 4. Now I have 2 of the 3. I'm going to go back to one of the original ones. I'll use b, which is x plus y minus z equals -2, and I plug in what I have. So x is 1. I don't know what y is. Z is 4 equals -2. So y minus 3 equals -2, y equals 1. And so I have a coordinate point of 1, 1, 4. We're going to do one more example, and what we're going to do with this is show you how you can deal with it when it's missing variables, even though we have 3 different ones. So what I'm going to do with this, I'm still going to keep this as a, but what's going to happen is I'm going to fill in placeholders. So this is 3x plus 2y, and it's missing a z, so I'm going to put in 0z. Do the same thing with the rest of them. This has 6x, it's missing a y, it has 2z, and it equals 4. And then for C, it's missing an X. Again, I'm going to label this B and C. I want you to pause the video for a few minutes and I want you to work on the method that we did in number 1. This time though, I want you to cancel out the X's. So only cancel out the X's. That way you can catch your mistakes when I show you the answers in a second. Now, what you'll notice here is that I did A and B. And when I cancel out A and B, I got D, which is -4y minus 2z equals 6. And what you should notice about it, we have a y and a z. But if we backtrack over to D right here, you have y minus 3z equals 2. So even though I could do another combination, either with B or C or A and C to cancel out the x's, I really don't need to. I'm going to use C. So I bring down C down to the bottom, and I take the y minus 3z equals 2, and I cancel out the y's then. Then what happens is those y's cancel out. We're left with z, and I figure out that z is -1. I backtrack it, and I figure out what y is, which is -1 down here. And then once I find -1, I can put it into b, which will help me find x, which is 1/3. So earlier in the video, I talked about we'll see what we're visually is going on here. What happens is with X, Y, and Z, we're talking about a three-dimensional plane. So you can kind of see in front of you some images of three-dimensional planes and how they kind of cross. Now, what we're really focusing on is this right here in the middle, where it's 3 planes that intersect and they cross at one individual point. So that's what we're kind of looking for. But other things can happen. You could get no solution where the planes are parallel to each other. Or you could get where they meet up right in the middle and it actually is a line of infinite line solutions.